In this video, I will show you how to solve a system of equations using the Casio fx-115 ES Plus. We will start by solving a 2x2 system, which simply means two equations and two unknowns or two variables, and then we will end with a 3x3 system. So the first thing you should do is make sure both equations are in standard form. That's ax plus by equals c. And let's take a look at equation number 1, which reads 2x minus 3y equals negative 8 and x plus y equals 6. We can see that both equations are in ax plus by equals c form. So what I did here was I simply rewrote the system so that we can focus on the coefficients and the constant terms, because those are the numbers we're going to enter into the Casio. Okay, so let's go over and hit mode and then select 5, and then we're going to pick option 1 because the equation looks like ax plus by equals c. We now have a matrix that appears, and we're going to enter in our ABCs, and we have them identified over here. A is the number in front of x, B is the number in front of y, and C is our constant term. So over here, well, let me go here. In our first equation, the number in front of x is 2, so we enter in a 2 equals, hitting the equal sign puts it in position, negative 3, and then negative 8. Now we drop down to our second equation, and we know that if an equation or if a variable does not have a number written in front of it, it is understood to be 1. So 1, 1, and 6. All numbers are entered. We hit equals again. Casio tells us that x is 2 and y is 4. So that would be the solution to our system. So if we were to go graph these two lines on a coordinate plane, they would intersect at the point 2, 4. Alright, let's try another one. We'll clear the Casio and then clear the matrix. Okay, so the first thing you want to make sure is that your system or the equations in your system are both in standard form. And although this one looks like it's in standard form, it's not quite, because we have to, the x and y terms have to switch places. So I did that here. I wrote my x term first, then my y term, and then my constant. And then in the second equation, we're going to have to transpose this term to the other side. So since it's positive 5/4 x on the right of the equal sign, we know it will be negative 5/4 x on the left. So here it is. So both equations are now in standard form. I am ready to enter in my numbers or my values. So we have 5, 4, 2. And then in the second equation, we have a fraction as the coefficient of x, but that's fine. So we'll enter that in as negative 5 divided by 4. And then 1 and 2. All values are in. Hit equals again. We get x equals negative 3/5. So I'm going to go ahead and type that in. And let's see what y equals. Our y value, or our y coordinate, is 5/4. Pretty simple, pretty straightforward. I want to try another one. So let's see what happens here. So let's enter in, well, our system is in the correct form. Let's enter in our coefficients and our constants. So 2, -3, and 12, and then -4, 6, and 18, and we get no solution. So how would we interpret that in terms of a graph? It means that, if graph the first line, let's say it looks similar to this one, and then the second one, the two lines would be parallel to each other. So we know two parallel lines never intersect. That's why there is no solution. There is no ordered pair where the two lines cross. Okay, and we see that here on our Casio. No solution. Okay, let's see another case. Excuse me. I deliberately picked this one just to show you that the variables don't necessarily have to be x and y. Like in this system we have r and s, but we'll just remember that r will be represented as x and s as y over here on the Casio. Okay, let's enter in our coefficients. 6, -4, and 10, -3, 2, and -5. Infinitely many solutions. So what that means is actually this second line here lies on top of the first line, and of course in that case they would touch infinitely many places, therefore having infinitely many solutions. Alright, last but not least, let's take a look at excuse me, let me clear this. Let's end with a word problem that we will translate into a 3x3 system, and then we'll enter it into the Casio. It says John inherited $25,000 and invested part of it in a money market account, part in a municipal bonds, and part in mutual funds. After 1 year, he received a total of $1,620 in simple interest from the three investments. The money market paid 6% The money market paid 6% annually. The bonds paid 7% annually, and the mutual fund paid 8%. There was $6,000 more invested in the bonds than in the mutual funds. Find the amount John invested in each category. Okay, so this is the form of a 3x3 system that just means 3 equations and 3 unknowns, or 3 variables, x, y, and z. So when we translate that word problem into a system, it looks like this. So I won't go into how it was translated, but this is the translation. So I just rewrote it so that we can identify our coefficients and just took the dollar signs off of these numbers. So once it's set up this way so that all of our x's are lined up, all of our y's are lined up, all of our z's are equal sign, and then our constant terms, we're ready to go over to the Casio. Now we're going to have to go back to mode, hit equation again, and now we're going to select option 2 because it has x, y, and z equal to our constant term. Okay, so let's select 2, and we have our matrix, and once again we just enter in our numbers. So 1, 1, and 1. 0.06, find our last equation. One thing I want to point out here, if you notice in the original system there was no term for x. So when that happens, it means the coefficient of that particular variable is a 0. So when you're entering into your Casio, you have to put a value in for x. So I just simply wrote the x term in place and I put the 0 in as its coefficient, so that over here we enter in a 0. Did I put in my 0? Let's see. Okay, and then 1, -1, and then 6,000. Okay, all values entered. We get x is 15,000, y is 8,000, z is 2,000, and this is how we interpret those answers. So 15,000 in a money market, excuse me, 8,000 in municipal bonds, and 2,000 in a mutual fund.